So far, we discussed about what is Kubernetes, how to set up Kubernetes. We use so far self-managed Kubernetes cluster. We have done a setup using Kubernetes self-managed Kubernetes cluster. As we already discussed, in self-managed Kubernetes cluster, we cannot, leverage all the features whatever we have in a cloud services. We cannot leverage the cloud services in a self-managed Kubernetes cluster. In self-managed, we have to manage the cluster. In self-managed Kubernetes cluster, we have to manage the Kubernetes cluster. We cannot integrate or use cloud services like storage, load balancers like ELB, and also scaling. Scaling, I mean to say auto scaling. Auto scaling of what? Auto scaling of cluster. Auto scaling of cluster, right? We cannot leverage the cloud services in a self-managed Kubernetes cluster. Suppose if something went wrong with your master, you need to manage. If you have a multi-master Kubernetes cluster, if one is down, other one will take care. But again, right, you have to self-recover. You have to recover the cluster yourself if something went wrong. Auto scaling of cluster, auto scaling of nodes, right? It will not there in a self-managed Kubernetes cluster. If I go for a managed Kubernetes clusters, managed services or managed Kubernetes clusters like EKS, GKE, or AKS, we have like highly available Kubernetes cluster, high availability. We can integrate with other cloud services like storage and load balancing, load balancers, right? And we can also achieve auto scaling of cluster. I mean to say nodes, auto scaling of nodes. So we can achieve these things. And there is a one more way of setting up a Kubernetes COPS. Kubernetes operations is a software using which we can set up highly available and production ready Kubernetes cluster. highly available, which means production ready, Kubernetes cluster. Basically, KOPS will leverage, basically it will create cloud services like auto scaling groups, and launch configurations for master machines and worker machines. Basically, KOPS, if you go for a KOPS will create AWS auto scaling groups and launch configurations. So it will create 2 auto scaling groups and launch configurations. One for master, one auto scaling group and launch config for master group or master machines, and one auto scaling group and launch configuration for worker machines. For worker machines. So these auto scaling groups and launch configuration in the cloud will manage the cluster. So these auto scaling groups will manage Kubernetes cluster in cloud, I mean AWS. So we can set up highly available Kubernetes clusters. We can set up highly available Kubernetes clusters using this one or this one. So what is the difference between EKS and KOPS, right? EKS also highly available Kubernetes cluster. KOPS also highly available Kubernetes cluster. If I go for a KOPS, right, we don't have a control plane. Control plane will be completely owned by AWS. We don't have a control on the control plane. What are the control plane components, guys? EKS, the complete control plane will be owned by AWS. We don't have a control on the control plane components like API server, scheduler, etcd, and controllers, control managers. So these, we don't have a control, that will be completely owned by AWS. Right? You cannot see your control plane machines. If you create a EKS, that will be completely owned by AWS. That will be in AWS control. When I create a KOPS, you are going to have a master machines, I mean to say control plane components, and also worker machines, worker auto scaling group. You have a control on the control planes if you want to customize. When I go for a EKS, so we don't have a access, or basically we don't have a control on the control plane. Control plane components will be taken care by AWS. So you can create a worker groups and you can use those worker groups with that control plane. So We'll see now how to set up a EKS cluster. Benefits we already discussed, like it's highly available Kubernetes cluster. It's a managed Kubernetes service. We can set up Kubernetes in multiple ways, guys. I will show now using AWS Management Console, using GUI. Using GUI, we can set up EKS Kubernetes cluster, and also using Terraform also you can set up a Kubernetes cluster. If you execute Terraform script, it will set up a Kubernetes cluster. So for now, I am going to show how to set up using GUI, graphical user interface. Later, I will share this. I have a script, a Terraform script. If you run a Terraform script, EKS cluster will be created. I will be sharing the Terraform script also. So before we set up, we will try to understand EKS, Amazon Kubernetes Service, is fully managed Kubernetes service. It's fully managed Kubernetes service. EKS is the best place to run Kubernetes applications. EKS is the best place to run Kubernetes applications because of reliability and scalability and security. Reliability, highly available, reliable, and scalability. We can scale our clusters. We can scale our clusters, not only the pod. We can scale our servers, our nodes. Auto scaling of nodes also possible in a EKS. And also EKS can be integrated with other services, other AWS services such as Amazon auto scaling groups, IAM, VPC, and load balancing, all these concepts. We can scale and load balance our applications in a EKS Kubernetes clusters. And EKS makes it easy for you to run a Kubernetes on AWS without needing to install and operate and maintain your own control plane. You no need to install, you no need to operate, you no need to manage or maintain the control plane. It will be managed by AWS. Managed control plane. So in EKS, AWS will manage the control plane components. So EKS provides scalable and highly available control plane that run across multiple AWS availability zones. AWS has region and availability zones concept, right? So the control plane, API server, scheduler, etcd, multiple replicas, multiple control planes, multiple etcd for high availability will be running. So EKS automatically manages the availability and scalability of the Kubernetes API servers and etcd. So it's a managed control plane. So if you understand this, right, the control plane nodes AWS will manage. We don't have a access or we don't have a control on these control plane components like API server, scheduler, etcd. Multiple replicas will be there for high availability that will be managed by AWS. In our account, in basically we can manage the worker group, how many workers you need, right? What type of workers you need. We can manage workers, but this will be completely owned by AWS. Now, let's see how to set up a EKS cluster. So everyone has AWS account with admin privileges, right? So what we will do? We will use AWS to create a EKS cluster. And we need to create a one machine to access the EKS cluster. We are going to create one instance to access the EKS cluster using kubectl. So first I will create a cluster, then I will access, then we will create one server to access the EKS cluster. First we will create a EKS cluster. Later we will create one machine where we will install kubectl, to communicate with EKS cluster. So first let me create a EKS cluster using AWS console. We will follow these steps and we will create a EKS cluster. So first let me log into AWS. So I terminated self-managed Kubernetes cluster. I removed self-managed Kubernetes cluster which I created. Now we will create a EKS cluster. First we need to create a IAM role. Using that IAM role, right, we will create the cluster. So in AWS we already discussed, guys, what is IAM? Identity and access management. We have a user, we have a role, we have a group, we have policies. We already discussed in AWS. So we are going to create a IAM role. There is a service in AWS called IAM, Identity and Access Management. So first I'll create one role. Create a role. Let me show what you need to do. Go to services, go to IAM role. IAM, basically search with IAM, Identity and Access Management. So you will land in this page. Here you have a roles. We need to create a role, one role. Select this use case, EKS. Select EKS cluster, this one. So you have to select this role, EKS cluster, right? Then here, just this EKS cluster policy, it has all the required details, all the required access. Okay. So you just select that EKS cluster. So this role has this policy. So let's create EKS cluster role. Now I have a EKS cluster. I can create a Kubernetes cluster in a default VPC, or if required, you can create your own VPC for Kubernetes cluster, dedicated VPC. So if you want to create a Kubernetes cluster in existing VPC, you no need to do this step. If you want to create a EKS cluster in existing VPC, you no need to create a dedicated VPC. Or if you want to create your own dedicated VPC for this EKS cluster, you need to create a VPC. So I can create EKS. I can create a EKS in the existing VPC, whatever VPC I have, right? So if I see as of now, I have this VPC, default VPC, this default VPC. I can create a EKS cluster in that VPC. I can go to EKS, right here, EKS, Amazon EKS. If you see, the charges will be something like this. For control plane, they will charge. For control plane, they will manage the control plane, right? So they will charge, control plane charges are separate, and worker node charges are separate. Complete control plane will be managed by AWS. The charges will be applicable for control plane. This control plane will be managed by AWS, and worker nodes as per the worker nodes, whatever EC2 instances you are selecting based on that. Now, I don't have any clusters. I don't have any clusters. Right? If you see EKS clusters, I can create a EKS cluster. Now, I need to select a VPC. So I can select a default VPC also. Now, instead of creating a servers in a default VPC, the EKS Kubernetes cluster, I am trying to create a Kubernetes cluster in a dedicated VPC. If you see, I am creating a cluster name. What version of Kubernetes? Version. And whatever IAM role we created, right? In IAM, select the IAM role to allow the Kubernetes control plane to manage AWS resources on behalf of you. So control plane will manage AWS resources. So that control plane requires permissions to AWS resources that we are providing via IAM role. So here I need to select a VPC. I need to select a VPC. So you can select this default VPC. If required, you can select this default VPC instead of creating another VPC. But for now, I'm going to use a dedicated VPC for that cluster. So let me cancel. As of now, I just created IAM role. I just created IAM role. Now, what I will do? Create a dedicated VPC for EKS cluster. Create a dedicated VPC for EKS cluster using CloudFormation. So you can use CloudFormation also, CloudFormation templates. So instead of creating a VPC manually, like creating a VPC, creating a subnets, creating a route table manually, we can use Terraform, or you can use CloudFormation infrastructure as a code to create a VPC. So I'm using CloudFormation template. So this will have all the details, like how many subnets has to be created, how many route tables has to be created. So it has some details in the YML format, AWS concept, CloudFormation template. So we are going to use this CloudFormation template to create a VPC. So let me go here. Now I just created IAM role. I just created IAM role. Now, let's create a VPC using cloud formation. So search with cloud formation template, cloud formation. Click on this create stack. Now I am going to provide this URL. The cloud formation template URL. Okay. Guys, let me show it again. Go to here. Go to cloud formation. Create stack and provide your URL. This URL has EKS for VPC. It has some details like VPC, subnets, route table, all the information. So click on next. So it is going to give some details, how many subnets it is going to create. Right? If you see, this is the VPC range, and it is going to create 2 public subnets, 2 private subnets with this range in that VPC. I'm just creating a VPC, guys. Stack name you can give EKS VPC, something like this. So you just create, just click on next, next. Now, if I go to VPC section, now AWS is creating, this cloud formation is creating the VPC for us. Like it is like infrastructure as a code. So now, after some time, our VPC will be ready. If I go to VPC here, now I can see that cloud formation template is trying to create a VPC. It is creating a subnets. If you see, it has created 4 subnets. It is creating route tables. It is creating a route table. It is creating a internet gateway for that VPC. So it will take some time. So if I go to cloud formation, the cloud formation template, that creation is in progress. Now we are creating a VPC for EKS cluster. We are creating a dedicated VPC instead of using default VPC. So this is optional. If you want to practice, this is optional. But in real time, you will have your cluster in a dedicated VPCs. So now it will take some time. Let's wait. It has to be done. This is create in progress. After some time, you can see this will be done. Once this step is ready, then we can go for a EKS and we can create a EKS cluster now. As of now, we just created a VPC. We just created a IAM role, which we are going to use to create a EKS cluster. Now, here you can give the name and continue to next step, or you can go here and create a cluster. So now, let me create a cluster. Create cluster. I'm giving a cluster name like this, EKS demo. This is the default version as of now. The stable version of Kubernetes 1.18. It is supporting EKS. Here you have to select the role which we created, IAM role. Now, click on next. Now here you select the VPC which we created in a previous step. Instead of using default VPC, I am selecting this VPC. I am going to select this VPC. Select this VPC. So automatically the 4 subnets got selected. Whatever we got in this VPC. Then select this security group. EKS control plane security group. Select this security group. While creating a EKS cluster, I am saying under which network, under which VPC, under which subnets, right? And again, cluster endpoint access, cluster endpoint access. So cluster endpoint, like API server access. So do you want to access the cluster publicly, or you want to access privately, or you want to access API server in public network as well as private network? They have given 3 options. The cluster endpoint accessible from outside of your VPC. If you want to access API server, basically your control plane, outside of this VPC, you can select this option. Public and private. If you want to access the endpoint API server from outside of VPC and within VPC also, you can select this public and private. If the API server you want to access only within VPC, suppose you have a kubectl installed in a different network. You have a Kubernetes client machine in a different network. And if you want to connect to this cluster, if I select this one, it will not work. Private endpoint, I mean to say Kubernetes API server can be accessed within the same network, within the same network. So if API server, you will not expose it publicly, public network. API server you will not expose to public network, right? Only private within your network. Within your network, right? You can select private. Suppose you have a scenario where I have to connect to the API server from a multiple networks, multiple VPCs, different VPCs. Then you can select public and private based on your requirement. So most of the cases it will be within the network. Most of the cases it will be within the network. So you can select private or you can select public and private, this option, public and private. So the cluster endpoint is accessible from outside of your VPC. Worker node traffic to the endpoint will stay within your VPC. So this is cluster endpoint access, how you want to access your API server. Okay. For now, let's select public and private so that you can access your Kubernetes cluster from your laptop also, if you want to access from your laptop, because I am selecting a public and private. Now, if you want to integrate with CloudWatch, you can enable this one. So it will send all the logs of control plane to CloudWatch if you want to integrate with CloudWatch. As of now, I am not selecting all these options. Now, let's create a cluster. Now it will take some time. Now we are only getting this control plane. Now we are only getting this control plane. We are getting a control plane. This control plane. This AWS will manage. We don't have a access. We don't have a control on these things. We just created a EKS control plane. Once this is ready, then we can create a worker group and we can add a workers. How many workers you need to have for that cluster. So it is going to take some time. Now it's going to take some time. Now EKS cluster is getting ready. Once the cluster is ready, then here I can add a workers. I can create a worker group, node group. I can create a node group. As of now, this option is disabled. As of now, this option is disabled because the EKS cluster is still getting created. So we will wait for some time till this cluster is successfully created. Then only I can add a worker group. It may take some time, guys. It may take 4 or 5 minutes. Okay. Yes, this is where we have a control, right? So here, compute, when we are creating a worker group, you can say what type of instance you want to create, what is the AMI. For workers, yes, you have a control. This is we are deciding in our account, customer account, in our account, we are deciding, we are creating a node group, worker group. This is we can decide how much CPU, how much memory, what type of instance, right? That we can decide. So let me show that once this is ready, once this cluster is ready, right? I will show that. We have to create a worker group. As of now, we don't have any workers. Master, you don't have a control at all. You don't see any servers in your account. You don't see any servers in your account. Nowhere you can see the masters, the control plane. That will be completely managed by AWS. You don't see a master, you don't see a control plane servers in EKS. So that is completely owned by AWS. You don't see in your account. What you want to scale, why you need to scale master? Already master is highly available. They have multiple replicas. What you want, if there is a lot of load, which one you want to scale? Are you going to scale masters or are you going to scale workers? If there is a lot of load on your applications, where your parts will schedule now? Where your parts will get scheduled? On the nodes, right? If there is a lot of load, which one you will scale? Your nodes, that you can scale. Master is already control plane is highly available. They are going to have a multiple replicas of control plane that will be managed by AWS. These workers based on the load, you can yes auto scale. Now let's see if cluster is ready. Still it is getting created. It may take some time. Let's wait. Yes, that is what we are trying to get, right? So AWS EKS is highly available multi-master managed Kubernetes cluster, right? It's a multi-master. They will have a multiple control plane, multiple replicas, highly available control plane, and also worker machines. Worker machines is again worker nodes. Again, it is going to leverage the AWS auto scaling concept. When we are creating a worker node, basically we are creating a AWS auto scaling group. When I create here, it is basically one AWS auto scaling group for a workers. So if one worker goes down, that AWS auto scaling will recreate the worker automatically. And we can also have a auto scaler, cluster auto scaler. So based on the load, it can increase and decrease the workers. So it's highly available, managed Kubernetes cluster. Unless until the server is ready, I cannot create a worker group. Now, now we have a AWS account. Within that AWS, we created one VPC. We created one VPC in Mumbai region. AWS Mumbai region. We created a VPC. We created a VPC. Now we created a EKS cluster. EKS cluster. This EKS control plane will have a multiple replicas, multiple EKS control plane. It will have a multiple replicas, multi-master. It's kind of a multi-master, but we don't have a control on this one. This will be completely owned by AWS. Multiple control planes. Like multiple replicas of control plane. You have API server, scheduler, etcd, something like this. Here also you have a multiple like API server, scheduler, etcd, multiple control plane. Now we need to add a workers. We need to add a worker group once this is ready. Guys, there will be a load balancer in front of this control plane. There will be a load balancer in front of the control plane. There will be a ELB. Because multiple replicas, multiple API servers, highly multi-master, right? So whenever we access kubectl, whenever we execute kubectl from any server, suppose this is my Kubernetes client where I have a kubectl installed. This kubectl is configured with kubeconfig that will have a ELB. So request goes to load balancer to the masters. If there are multiple masters, it will talk to one of the replica. Request goes to one of the API server in this cluster. So as of now, while creating a EKS, I have selected access as public and private access, private endpoint access. So this Kubernetes client, I can access Kubernetes cluster, this cluster from a VPC, same VPC, or I can access from the server, which are in different VPC. And also I can access from my laptop also. This is my laptop. Let's assume this is DevOps, right, system. Here I just need to install kubectl. I should have a access. So I can access from here also, that API server. So now my cluster is ready. Still it is getting created. Meantime, let me create one machine. Let me create one server. How can I access that Kubernetes cluster now? I need a server where I have a kubectl. I need a server where I have a kubectl, only Kubernetes client. Now I am going to create one server. I am going to create one server to access that Kubernetes cluster. I am creating one server to access that Kubernetes cluster. Let me create a server. Any server, you can use Red Hat, you can use any server, because that is not a Kubernetes machine. That is not a master, that is not a worker. Just a machine from which you can access Kubernetes cluster. So let me create this server. Now I can create in this VPC also, or in this VPC also, default VPC also, because while creating a EKS cluster, the endpoint type I have selected public and private. The endpoint type I have selected public and private. So this Kubernetes can be accessed from this VPC or from a different VPC or from a public network also. So let's create maybe this VPC also fine, default VPC. You can create a server from where you can access the Kubernetes cluster. So this is Kubernetes client server, just client server. This can be Jenkins server also, guys, right? This can be CI/CD server. This can be any server from which you want to access the Kubernetes cluster. This can be a Jenkins server or any server. From this, we can access the Kubernetes cluster. From this, we can access the Kubernetes cluster. Okay. So for now, let me show only running servers. So this can be any server from which I can connect the Kubernetes cluster. So what software is required now in this machine to access my Kubernetes cluster, to talk to the API server for deploying or updating my application? What software is required to install? We need to install kubectl first. We need to install kubectl first. So let's install kubectl. Let's install kubectl by connecting to this server. This can be Jenkins server, this can be any server. So let's install kubectl. Just install kubectl. Kubectl, Kubernetes client. Okay. So let's follow this instruction. Just install kubectl. So I downloaded kubectl binary. Change, give executable permissions, and move it to user local bin. Now I have a kubectl installed. Now I have a kubectl installed. If you see kubectl installed, but will it able to connect to my cluster now? Kubectl get nodes. I just have a kubectl installed. Will it able to connect now? Kubectl get nodes. I just installed kubectl. What is required now? What is required now? What is missing? What is missing? What do we need to have? We should have a kubeconfig file. Kubeconfig file that has a cluster information. That has a cluster information. I should have a kubeconfig file that have a cluster information. So do I have that file generated? Do I have that .kube folder? Do I have that kubeconfig file? Now, how can I get the kubeconfig file for a EKS cluster? I don't have a master machines, right? I don't have a master machines. I cannot go inside the master and grab the kubeconfig file. I don't have a master machine. If I have a master machine, I can go inside the master machine. I can grab the kubeconfig file. Now, that control plane is completely owned by AWS. Now, how can I get the kubeconfig file? What software is required to get the kubeconfig file? Now, we need a AWS CLI. You need a AWS CLI. You need AWS CLI to get the kubeconfig file. So you need to execute some command to get the kubeconfig file. So you need to execute this command in that server. In that server, you need to execute this command so that you will get the kubeconfig file. If I want to execute this command, AWS command, what software is required in that server? I need to execute something like this. AWS EKS update -config your cluster name -name cluster name. What is the cluster name I have given? I think EKS_demo and -region. Under which region my Kubernetes cluster is there? AP South 1. I need to execute this command to get the kubeconfig file. AWS EKS update config cluster name and region name. Do I have a AWS CLI installed? AWS, right? We don't have a AWS CLI. That's why I am getting this error. So let's install AWS CLI. I am trying to make you understand all the concepts now. So I am first showing the problem, then we are trying to use. So let me install AWS CLI version 2 on a Linux. I want to install AWS CLI on a Linux. So just follow this instruction. So let's get this. So there is a dollar, that dollar I will remove. So now I have downloaded this zip file, AWS CLI zip file, extract, unzip. If you don't have unzip, let's install unzip. So now let's extract. Let's extract. Then install. Now we have a AWS CLI installed. Now we have a AWS CLI installed. Now let me execute that command. Now I am going to get another issue. I am going to get another issue. So now the command is update kubeconfig. In the version 2, it got changed. So this update config is in AWS CLI version 1. Now I installed AWS CLI version 2. Instead of update config, it will be update kubeconfig. Instead of update config, it will be update kubeconfig. Now what is the problem now? Now what is the problem while executing this one? Why it is not getting the kubeconfig file? What is missing now? What is required now? I no need to give. I am just giving a cluster name and region name. Now AWS concept. Do this server has a access, or do this server has a permissions to get AWS EKS related information? Do I have a permissions for this server? This server, do I have a permissions? Did I configure this server with some AWS role or AWS user? So this doesn't have a permission. Now we need to create some role. That role should have a access. That role should have a permissions. That role should have a permissions to EKS cluster. So now let's again go back. Let's again go to IAM. Guys, since this is in AWS itself, do I need to use user or do I need to use role? Which one is preferable? AWS concept. Now I want to give a permissions to this server. So since this server is in AWS itself, do I need to configure this with the user or can I use role? We can use role. So now let's go to IAM. Let's go to IAM. is taking some time. Let's go to IAM, create a role. So select EC2. Here, what I can do, I can select admin access so that I will have a complete administration access, complete AWS access. So complete AWS access, you can select this one, or you can create your own policy. If you want to give access to only for specific services, you can create your own policy. So for now, I am not going to create own policy. For now, let's select administration access. Or if you want to create own policy, AWS concept, guys, I am like, here you can create your own policy, something like this. If you select this, choose service, select EKS, and again, what type of permissions you want to give for this, right? If you want to give read-only permissions, list permissions, right? List clusters, right? If you want to give write permissions, create cluster. So you are based on your requirement. For now, I am not going to give write permissions. I am going to give only read and list. Read only permissions. If you want to give, you can give. And for what cluster you want to give a permission. If you want to give a permissions to specific cluster, you can again select. If you want to give a permissions to specific cluster, again you can select what cluster. If you want to give all, right, you can give all. Or if you want to give specific, you can select here. Under which region you have a cluster and what is the cluster name, right? You can provide all these details here. So you can create a specific policy and you can attach this AWS concept. I am not again repeating here. So for now, what I am going to give? Administration access, full permissions for now. Okay. So let's go back to role. Let me create a role, EC2. I am selecting this admin access. Admin access. Now let's go back to EC2. Let's go back to EC2. Select this server, actions, security. Now attaching that role that has a complete access, admin access. He can do whatever, right? But in real time, based on the scope, based on the use of this server, you are going to give specific permissions and attach. Now, if you see, now I can execute AWS EKS list. I can list the clusters. How many clusters are there? AWS EKS list clusters -- region AP South 1. So now I have one cluster. This is my cluster name. Now I can execute. As of now, I don't have that folder, that file, that .cube, right? Now I can execute AWS EKS update kube config, update kube config, hyphen name, this EKS, this is your cluster name, hyphen region AP South 1. Now if you see, it has generated one kube config file. It has generated one kube config file. It has generated one kube config file. In this current user, in the home directory, it has generated kube config file. Now I need to use one more software I need to install. I need to install IAM Authenticator. There is a software called IAM Authenticator. If you see, as of now, I don't have that software. That's why I'm getting this error. We need to install one more software called IAM Authenticator. One more software called IAM Authenticator. So we need to install IAM Authenticator. Let me install IAM Authenticator software. Now, in a Linux, right? If you want to install, you can follow this instructions, Linux instructions. So download this software, IAM Authenticator software. Then change, execute, give executable permissions. Then we are just adding the path, exporting the path. Now, IAM Authenticator is installed. If you want to check, you can check this by executing this command. IAM Authenticator is there. Now, so this is I may need to use user here, not the role, because the problem here I will tell you. Now Kubernetes cluster is trying to connect to the, kubectl is trying to connect to the Kubernetes cluster using this endpoint. Request is going to the API server. API server will try to authenticate from which user your request is coming. If you see, it is going to use whatever user we have configured in this server for a authentication purpose with API server. If you see, it is going to use user. For authenticating with API server, guys. For authenticating with API server, as a which user you are trying to execute kubectl commands. As a which user you are trying to execute kubectl commands. So here I may need to configure with user in this server. So I am going to use maybe root user credentials instead of role. You can use root user credentials, access key and secret key. So here, if you don't have an access key and secret key, create an access key and secret key. So I don't have, look, like I am going to create an access key and secret key. So let's use this access key for now. This is root, sorry, AWS configure. Access key is this. Secret key is this. The region AP South 1, the default my region. Preferred output format, whatever you want to do. Now let's use this. As of now, request is going to the API server as root user of your AWS. So that root user has a permissions to deploy your applications in a Kubernetes cluster. Now, if you see, request is going to this kube config, request is going to this server. This is one load balancer. This is talking to the control plane. This is talking to the control plane. Request is going to the load balancer. This load balancer is for your control plane. Then it is talking to the control plane. Now, kubectl get nodes. Why I don't have any nodes? Why I don't have any nodes as of now? Did I created a node group for EKS cluster? Did I created a node group? As of now, I have a EKS cluster. This is ready. This is my endpoint, basically API server endpoint, load balancer of API server. Now I have a EKS cluster, but can I deploy the applications now? Can I deploy the applications without workers? If I deploy something, will it work now? I don't have any nodes as of now because I have not created a worker group. So now let's create a worker. Let's go to EKS cluster again. Let's go to EKS cluster again. Add a worker group. Add a node group here. EKS nodes. For creating a node group, again you need one IAM rule. First you need to create that. Before creating a worker group, you need to create a IAM role for your workers. You need IAM role for your workers. So you need to create a one more IAM role for your workers. So let's create, let me go to again IAM. This is for your worker machines. So let's create a role. So select EC2 as a use case. Here, you need to select these three policies. Worker node policy, EKS worker node policy. Select that one. This will have some permissions, guys. It will have some permissions like EC2 permissions, EKS permissions. Some permissions will be there. Some permissions will be there. So you need this EKS cluster policy. Select that one. Then next, CNI, networking interface. Right? It requires CNI policy. Select that one. And also, if you are planning to pull and if you are planning to push pull images from If you are planning to pull images from ECR, suppose you are using ECR where you are maintaining images. Suppose you are using ECR as a repository. Whenever you are deploying your pods that uses images from ECR, so your worker machines require permissions to use ECR. So select this one also, Amazon EC2 container registry, read only permissions, because it is only going to pull the images. Worker machines is only going to pull the images. So with this EKS node role for your worker machines, these permissions are required. So create a role. Then let's go back here. Select that role. Let's select that role. That whatever role we have created. Now here, it comes what type of machine you want to create. What is the AMI you want to use? So these are the AMIs, Amazon Linux AMIs. They are providing Amazon Linux AMI. So you can use these AMIs and what type of instance you want to create. What type of instance you want to create. While you guys are practicing, maybe you can take T2. T2.micro is not there, guys. Here, T2.micro is not there. You can maybe select whatever you want to use, maybe T3.small, T3.medium. So the charges will be applicable. The charges will be applicable for EKS cluster as well as workers. Now I am going to use T2.large machines, T3.large machines. T3.large, 8 GB RAM, because I want to demonstrate some like Prometheus, Grafana, right? It requires lot of space. I want to deploy Prometheus, I want to deploy Grafana. So it requires lot of space. I need lot of resources. So that's why I am using T3.large. If I use these servers, I cannot demonstrate Prometheus, Grafana, all those things. So I'm using T3.large. And here, what is the size of EBS? For now, let's leave it 20. What is this minimum size, maximum size, desired size? How many minimum servers you need? How many maximum servers it can create? AWS auto scaling. This node group is nothing but a AWS auto scaling. Now minimum I am saying 2, maximum I am saying 5. So now how many workers will be created? Now 2. So under all these VPCs, it will be under all these VPCs. Okay. Now, what is the key pair which you want to use? What is the key pair which you want to use for these servers? Suppose you want to log into these servers. This is the key pair. So now let's create. So now if you want to add a tags, I have not added tags. Okay. If you want to add a tags, you can add a tags. Let's create. Now worker machines are getting created. Now if I go to AWS auto scaling group, if I go to AWS auto scaling group, here I can see one group. After some time, here I can see one group for workers. So AWS auto scaling concept is being used as part of EKS. It will take some time, some time, guys. It will take some time. We have a EKS cluster. Now we have created a node group. Again, it will take some time to create a worker machines. Now, same thing I can do using Terraform also. If I execute Terraform scripts, everything, whatever I have done so far manually using UI, I can do using Terraform also. If you have a Terraform scripts, right? Same thing I can create using Terraform also. If same thing I can do using this Terraform scripts. So here we are defining a VPC details in this Terraform script. Like VPC details, EKS cluster details, worker node details. We are creating all the required IAM roles, everything as part of Terraform script. If I execute this Terraform script, whatever I have done manually so far, you can create EKS cluster using Terraform also, infrastructure as a code. Now worker machines are getting created. It will take some time. Let's wait. Now if you see, there will be a one auto scaling group for worker machines. There will be a one auto scaling group. And it is using some launch configuration. Guys, did I install Kubernetes softwares, Docker software manually in a worker machines? Worker machines are created by auto scaling. Auto scaling is using this launch configuration. Auto scaling is using this launch configuration, right? So all the details are part of your launch configuration. User data, if you see, it has a user data which will install. If you see, there is some script which get installed. This script will execute all the Kubernetes softwares, and also it will join the cluster. It will join the cluster, right? So everything is automated. AWS is taking care. Now, if you see, who created these two machines now? T3.large. What are these machines now? Which I can see here. Our Kubernetes worker machines. Now, can I see these two machines now? Now I have a Kubernetes cluster ready. I can deploy the application. I can deploy some application. Again, same thing. Java web app.yml, right? I'm going to deploy some application. That's it. So let me use whatever YML. I no need to type again and again. You already have some. So let me use. Now I can create a service of type load balancer also now. I can create a service of type load balancer also. I can create a service of type load balancer. So I will get a load balancer. You no need to give a node port, automatically it will assign. Now load balancer. Just cross check the labels. App, fine. Now If you see, as of now, I don't have a load balancer. As of now here, if I go to AWS ELB, load balancers. As of now, I don't have any load balancer. Now, the moment I apply this, I will get a load balancer also for this. Now, if you see, pods are getting created, service also getting created. Now, this is load balancer, external IP, load balancer service. Now, AWS EKS, we can leverage external load balancers. Now, you can see, I got a load balancer. That load balancer is pointing to which instances as of now? What are these two instances? What is these servers? These servers are again worker nodes. Now, if you see on which port the request is sending to those two servers, what is this port? This is the load balancer port. What is this port? The request is going to this port on those two servers. What is that port, guys, here? What is that port? The service port for this one. Now request comes to worker machines on this port. Then what this guy will do? It will route the traffic to the pods. It will route the traffic to the pods. Now, why it is not ready as of now? If you see instances, now it is in service. Earlier it was out of service because that pod is not completely up and running. Now, can I access this application using this load balancer? This is my load balancer. Inside that, I have an application. My application context is this. Now, request is going to load balancer to the Kubernetes service to the pods. So tomorrow we will see how can I map domain, how can I use domain. So instead of using this one, again it is not human friendly name or human, as a human I cannot remember this name. So now we have a load balancer. Tomorrow I will explain how to map domain with this load balancer so that I can access something like this. I have a domain, Mithun Tech devops.co.in. This is my domain. So I want to access something like this. I want to access something like this. So tomorrow we will see. Tomorrow we'll continue with this. And also later we will see what is ingress, how to use ingress. Right? Tomorrow we'll continue, guys. And also I will demonstrate the cluster autoscaler. As of now, we have only two nodes. As of now, we have only two nodes. If my cluster is running out of resources, automatically, I want worker machines. I want nodes to be created and added. So tomorrow we will continue on these topics. Okay. Today we just set up Kubernetes cluster using EKS. Try to set up a cluster. We'll continue tomorrow, guys. And also, if you see, now can I use dynamic volumes? Can I use dynamic volumes now? Can I just create a PVC? Will it able to create a PV now in this cluster? Tomorrow 6 a.m. Sunday 7 a.m. Okay, tomorrow 6 a.m. only, Sunday 7 a.m. So now what type of volumes it will create? What type of volumes it will create? What is the provisioner? EBS volumes. Okay. So tomorrow we'll continue on these items, guys, these topics. Okay. We'll continue tomorrow. We have a class at 6 o'clock. Sunday also we have a class, guys. Sunday I will take from 7 a.m. Thank you. I'll share this